Hi guys, contest will start in like 1 minute. I guess contest will start at 8:05. I hope, not I hope, yeah. I hope I do good. Let me share my screen a bit. I got some practice yesterday, right? After a while, I haven't been doing competitive programming at all, but I've got some practice, so I hope I can do better because of that. We have 23 seconds. Yeah, I'm at right time, guys. 5 seconds earlier to contest, and it is rated for me 2 over 30 minutes. Damn. Let's see how many problems are here. This is problem, yeah, but let's see how many problems. So for a permutation star R of length m, we call an index ugly if and only if I equals to max of till those things. So what do we call which index do we call ugly? If that is if I is the max in that prefix, okay? Since Simon's n is always ugly, Simmons has a permutation P of length and he can perform the following operation on P at most once. Swap two indices of I comma j. Find the permutation Q that can be obtained from P by performing the above operation at most once such that the number of ugly indices is minimized. So how can you do that? If you bring n to the beginning, ugly indices will become zero, right? If you bring n to the beginning, because that will be always max and it will become zero. That's the problem. We have solved the problem. Let's submit the problem. Just find n's position and swap it with 1 at most once, right? If n's position is 1, you won't do anything. So we have to output number of operations and we have to output the final permutation. Just swap n with 1. That's it. We just have to output final permutation. Done. Let's run this and let's submit that. Am I sharing my screen? I hope I am. Fuck, why is this happening to me now? When I was so quick, why is this happening to me? We wanted to make it zero. Zero is always possible. We want to minimize that, but zero itself is always possible. Let's go to the next problem. I hope I haven't made any silly mistakes. Yeah, this is my company shirt. See the drip. It's a jersey. It has my number written on it. The time I joined into the company. Does your company have such a cool shirt? Simons has n friends and a huge amount of cakes. To divide the cakes fairly, you are asked to help him solve the following problem. Find the minimum portion which such that n is the divisor of k power n. So we want to find the minimum portion which such that n is a divisor of k power n. Damn, that seems cool, right? So we want to find the minimum positive integer k such that n, so n is a value. Maybe k will be 1. Okay. N is a divisor of k power n. N is a divisor of k power n. Do you see that? It can be proven that answer always exists and we want to find the minimum one. Think about that for a minute. Uh, n is a divisor of k power n. Let's see what are all the primes that are in n. Okay, if you know all the primes that are in n, this seems difficult even if you're thinking about primes. So we have to write it what it means. Like let's try to write it a bit mathematically. What it means: n divides k power n. What it means if n divides k power n? This seems to never happen, but wait a minute, the answer always exists. Will it happen for k equals to n? But it can happen for something much smaller too, right? So let's say n equals to p1 power a1 up to so on this one. You can uh, take some GCD of all these things, okay? N power, like you can take some common element like GCD of a1 comma a2 up to so on am. You can divide n equals to something whole power GCD of a1 comma a2. I think you can write it in that way. Like let's try to write separate the GCD of n. Now what does n divides this means? Like k power n has this thing, right? So this power n, we have to like remove that power n. Like let's say we want something, this should be contained inside of, these powers should be contained inside of some case funds, like let's let that be q1 comma q2 up to so on, whole power n. So if you see, this is like something that you know, the prime representation, you know that. Am I overcomplicating the problem? I don't know, but I'm trying to write it mathematically and see what happens in here. uh, K power n. And what is k exactly? We want to find the smallest number such that this can happen, right? And if you see this, something is inside, and if you see this one is here, and if you try to see this thing should be equivalent, all the primes should match here. I think all these primes should be contained in this one. And if you try to think about that, maybe you can cancel this GCD, and you can cancel whatever is common between this GCD's power, and you can try to cancel whatever that is common between this n. After canceling that, those two will become non-replaceable. And then after you cancel that, I think this must be equals to, you want to find something, you know, this something, think about that well, you know, this something. So this should be equals to this. So this can have something extra. After you cancel GCD, this should be equals to this something power, whatever that is. That's it, because you cannot do further, you cannot take off common factors further. You have the prime factorization, you have the GCD of the numbers, you remove those GCD between these two things, and whatever is left, that should be this q1, because this cannot help you further. I think that's the answer. So let's just go ahead with that. Oh, I'll write the solution here. Find all primes, find a1 a2 and so on. Answer equals to uh, find g equals to GCD of a1 a2 and so on, comma n, because GCD of all this and GCD of this is just GCD of all of them, right? And then answer equals to n power 1 by g. Answer is just this, is our claim. Okay, all we need is, but how do we get this value back? N power 1 by g is the answer, is my claim. How do we get this value back? Let's try to verify this very quickly for 2 power 3. If you see 2 power 3, we have 3, and we have n equals to 8. GCD is 1. Two cube divides 2 power 8. Wait a minute. Wait a minute. This should be. Let's try to see how many somethings you can get out of this value. Okay? How many somethings you can get out of this value. If you try to care about that, because you're trying to minimize that, other things doesn't matter. So this should be something power, because you have to try to see this should be something power. And then you have to something power something. So how many things you have to remove from this value so that it will become less than or equals to n? This is the answer. We want jet such that this will happen, the smallest jet such that. But this seems fairly complex, right? Or there's also on that. I overcomplicated this. Maybe it has an easy solution. Maybe the answer is just all individual primes in there. Sorry for overcomplicating it. Maybe it's like P1, P2 up to so on that will always work likely. Oops, oops, oops. All the primes in there. That's it. Find all primes. Return their product. I should have guessed. I should have guessed. It's B, right? I should have guessed. I foolishly thought B is somehow this time difficult. I should not have done that. I really foolishly thought maybe this time B is difficult. Lemavo. I should have done better. But let's see, we have time at least. We haven't fucked the contest up. There are n blocks. The ith block mentioned li users in the order ai equals to. We have the users here, the array. Mm, you're going to post all n blocks. Let us maintain a sequence queue that describes the list of users you have recently mentioned. List of recent users that you have recently mentioned. You need to perform the following operation exactly n times. Create an unposted blog I, then post it. This will cause the following operations for each li in the order. If AI already exists in queue, then aij will move to the beginning of the queue. Otherwise, insert aij at the beginning. So we will get the recent ones. We have this ordering. Like you have to choose different orders, and then you have to make the lexicographically smallest queue after all n operations. You want the lexicographically smallest. Everything that has been there will present in the leaf. Will present in the list. Everything that has been there will present in the list, and we want to make the lexicographically smallest one. We have these values, and ai comma j is the user's index, right? And this is lexicographically smallest way to do that. So what you have to go for? Yeah, it goes in the same ordering. So what's the last block that you will do? Because the last block represents the last block controls the first elements, right? So what's the last block that you can do? In the last block, we have to first find the last block, and if we can do that, then we have to think of how this last block will influence the other things, right? Whatever the things that are present in the last block, the things that are present in the last block, those values, if they have come before, it doesn't matter because those values are influenced now. This is the best influence that they can have. So you remove those things and then you will solve the problem again. So it's all about finding the lost problem because they have the best influence coming at the last. So you can remove them from the above things, and then you can process the above things again in the same way. So can you find the last one to find the lexicographically smallest one? How does this one like work? Or they distinct in the same list? Are they distinct in the same list? I'm not sure. They need not be distinct in the same list. Okay, if they are distinct or if they're not distinct, what matters? Their last occurrence will matter because that will override this one too. So now you have an ordering. You have an ordering for each thing. What matters ordering? The ordering that matters. Now, if you have that ordering that matters, now you have to see how to choose something. Okay, you have this ordering that matters, right? And in this ordering that matters, you have to find lexicographically smallest one. You have to find lexicographically smallest one. Sum of L doesn't, or all test classes doesn't exist. So I think just find them, just sort them. Okay, you have these things. You have to find the lexicographically smallest one. How to find that? I think the complexity is fine. You'll find the lexicographically smallest one by trying to find the first minimum, and then try to find the next minimum, and then try to find the next minimum, up to so on. This complexity will be of L times. So sum of Li doesn't matter. So it will, the complexity will be Li times n if you do that. So Li times n should be fine. Each time we were able to remove the least element, it is complexity is Li times n. Okay? And then you will remove one thing. Now you have to discard all the things that are here, and then you can do it again and again and again. So each time, whatever you were removing, the minimum thing that you are removing, that will be, the complexity will be Li times n. So the complexity is good, the complexity is done. But how do you do that? You have to reverse them. First you have to reverse them. First you have to reverse all of them, let's say, and then you have to reverse all of them. You have to find the lexicographically smallest one, and then you have to, first you pre-process them, and then you reverse all of them, and then you keep removing, and then you keep removing. Okay, that's it. Let's find lexicographically smallest, remove all these elements from above, like discarding all of them anytime they come. You have to be careful about the complexity though. You have to skip some elements sometimes. Okay, for each thing skip some elements. Always try to find the next character and then compare them. How do you compare, and how do you get the least one? Like you have to find the first occurrence. You have to find the minimum. I think you can make a group. You can keep reducing the group one by one, by trying to find the best ones among them, and then you will have your the group will, when the group becomes one, that's your answer, right? I've done such similar code in the past, but I'm thinking what's the best way to do now again. Next, find the minimum list. Next, remove these elements from all other lists by marking them done. So I need not rely on this thing. I can just try to code that. Is there simple implementation? How to think about that a bit? Is there a simpler implementation? Can I do a bit simpler implementation than this? Maybe like to sort, because I don't think sorting works, because it will be like n square, right, per each turn. So I don't think it works. No, this is not wrong. What should I do is, first I have to push into temp, and then what I have to do is I have to reverse temp, and then what I have to do is Yeah, this is perfect. This seems perfect. Now we have these perfect orderings. In these orderings, now we have to find the lexicographically minimum one. Now we have to keep moving until our group will become one. Got that? And when it ties between two things, you can take any of them. So what should we do? What should we keep doing? What should we keep doing? So we're trying to find an ordering for each of them, okay? Not sure if this is right. Let me review this very quick. There has to be some simpler implementation. I can think of an implementation. I have to come from behind, find the first character. Now, character by character, you'll try to find, okay? Okay, we have leftover things among them. Find the first character. Find best characters in the left until one of them is empty. Okay? How do you do that? You have to find minimum everywhere. Okay? You have to find minimum. So first you have to, for int j equals, while true, like keep finding it. Okay? Okay, try to find the best character among everywhere, and then we'll minimize group. Try to find the best character. Now, you have to do it n times. That's why that was there. You have to try to find the best character. So all values are greater than 1. Am I overcomplicating this problem? Fuck no, I hope not. I am overcomplicating it a bit, but I don't know what data structure to use. I'm just trying to group them, find the smallest character, make the group smaller. So we're trying to find the smallest character. So by removing removed things, and then we're trying to see this value. Okay. So we're trying to find this among non-selected ones. We're trying to find the smallest character. Maybe we don't need left. We are trying to find the smallest character. Now we have to find a dot back minimum value. Okay. Empty is good for us. If something is empty, that's good for us, right? Now we'll try to. So we need left. Let this be an array. So among the leftover things, you have to find the min, and then again you have to go over the leftover things. Here itself, we can find the best. Remove only one thing, even if there are ties, minimum will be left. Until there is one thing. So whoever whose n value doesn't match with min, we will remove them. The left will become 0. And if you keep repeating this process, only left will become the things that are having minimum at the end. And now you know what's like. There is one thing that has left equals to 1, right? Yeah, one thing that has left equals to 1. So we'll select that. So removed should be a map. Why is this complex? Why is this complex? And then it has been selected. So in the beginning itself, it will not become it won't become left, and then we keep continuing the process. Let's see if it passes. Wait. We have to do something else. We have to choose one thing now. What? Okay, there is a case where all of them are equal. Now you're stuck. You keep on doing this thing. If all of them are equal, and now you can choose any of the remaining ones because all of them are equal. Okay, this seems correct now, but I have to think of it again. What is happening now? We have 1, and then we have 5, we have 2. So 152 is the correct ordering, and then after removing these things, we have 3, 9 is the correct ordering, and then after removing all this, you have 6, 4 is the right ordering. This we don't need this count of left, right? To break. Okay, if you haven't removed anything, if there is tie, you have to keep pushing whatever is left. Pushing from A of IDX seems fine. Wait, wait, wait. It's getting more complex. You have to pop that and then you have to add that. It's getting more complex. You have to pop that. You need not add that back because those will become removed, right? You have to pop that. Now you have to pop, else you have to pop that. You can pop that because those things will get removed. Okay? Wait, why did this become so complex for me? Am I overcomplicating it? Is there some just string structure you can just store them? All of them are equal, right? This should work fine. This seems correct somehow, but what is going wrong here? Have to be careful of complexity too. Why are you pushing something that is removed already? This will work fine. The fuck is going wrong here? Am I normalizing them? What is going wrong? Let me just output all A of I and see. So they look fine. So we got 152. And then we got 3 2. How? How? We are removing X, right? 152. But if we're too drunk to drive and the music is right, she might let you stay just for another night. This will be the right answer. But if we're too drunk to drive and the music is right, she might let you stay just for another night. Maybe this doesn't matter. But how though it should matter, right? It should matter. Like, how can that happen? Yeah, so this seems right. I definitely overcomplicated this problem. Hope it passes at least. Fuck. Even if you haven't removed anything, I think you should continue. You should continue. Thing and okay, if mn equals to 0, you can break. Because something has ended. This is the right condition to break. Let me submit this now. That's a complex algorithm. Maybe there is a simpler solution using some data structure, but this algorithm is not like so simple. Like the algorithm I have used is not that simple. I was worrying about complexity, so I have used this. Maybe there is some other algorithm that allows sorting. Maybe that allows try. Maybe it has there is some try algorithm. I'll get some water. That was complex to me, at least, right? There are so many things to take care of. But if we're too drunk to try, and the music is right, she might let you stay. How to turn on that light? I don't know. How to remove this? Should I remove my one mind shirt and have my this shirt that I have inside? I'll drink water and come. But if we're too drunk to try, and the music is right, she might let you stay. Water was right beside me. How to turn on that light? What if the children to cry? The music is right. Maybe the light spoiled. Maybe that light is spoiled. Am I scared of D? How? Division 2D. How can I be scared of division 2D? We can call an array B of length m cool if and only if there exists no index size as that bi equals to maximum of. So it cannot be greater than its neighbors. Greater than or equals to its neighbors. No element should be greater than or equals to its neighbors. Simons has an array. Initially, the array is a permutation. He must perform the operation until the array is cool. Choose an index size such that ai equals to maximum of this one. He can either remove I minus 1 or ai minus 1 from the array. After removal, the gap in the array appears on left and right sides of the gap will be rejoined. Find the minimum number of operations for Simons to perform. So there's a permutation. You have to find the minimum number of operations to remove, but you can only remove whenever this happens. You'll remove one of them. What is the array that doesn't have this at all? What's the array where there is no element that is greater than its neighbors? Can there be any maximum? No. So what should he make it like? What should he make the array to be? You have to make the array to be this, right? Because there should be no maximum at all. That means there can only be one minimum because after once it increases, it can never decrease. Hi, bro. Streaming everything, yeah? Okay, okay. Not streaming, it's a private, but I will post it later. You go in the You can roam around, I guess. No one will mind. No one will care. You went outside, kya, somewhere? Yeah, I went to work this meeting, work meeting. People in Bangalore just meeting up okay. Once in a week for fun. See you, man. See you. We can either remove those two things, okay? So finally, You have to make this one. What should we output? We have to output minimum number of operations. So this is a subsequence that remains, right? A subsequence remains. See, the longest such subsequence is a lower bound. Is a lower bound, like, because longest such subsequence, if you see the remaining one, n minus is a lower bound. So maybe that's the answer. So now you have to think. Let's say you have a subsequence, you have a v. Can you remove everything else that are not in the v? Can you remove everything else that are not in the v? Think of that. You have a v. Okay. You have this longest v. Try to see something else. Try to see the first thing that is not in this. Okay. Can this be? Can this be removed or not? Is our question. Right. We have few things that are not in this. Let's try to see two things between two things. Okay. If there are some things bigger than this, you can add that to your subsequence if you're looking at longest subsequence. So if there is something before that, it must be below and you can be removed. And if there is something in between, that can be added to the longest subsequence. But if something is above or if the something is below, you have to think about these two cases. If something is above, you may not be able to remove this thing. So maybe not the longest increasing is the answer, because you cannot remove the maximums, right? But can you brute force this point? Can you brute force this point somehow? Like trying to make this longest decreasing, what's the maximum number of things you can remove? And then you will also find this one for each of these prefixes, and then you have the answer. Even that's a thing that you can do. Longest decreasing. But if it to dry and the music is right, she might let you stay. So longest decreasing subsequence. Can you find that? For all lengths, longest decreasing subsequence for all lengths. If you find that, you will also find the longest decreasing subsequence for this one, and then that can be formed by removing such elements. So if you try to think of what is the longest decreasing subsequence here, look at the maximum here. It must be there at the start, because you cannot have something smaller before that. You cannot have anything before that. So it is max. And then we're trying to brute force this one now, and then max should be the first element. And then you want the next max from here, because anything smaller, because max can never be removed again. If you look at these elements, max can never be removed again. You cannot have anything, you cannot remove max without removing everything in between, because if there is something before max, all of these are smaller, so you can never remove max if there is something. But if there is nothing before max, removing max is bad. You could have instead kept the max. So it's always optimal to find the next max and then the next max and the next max. So if you're having this length of first max and then the next max and then the next max sequence, okay, and then you're having the new element, we'll just remove the things that are less than that, and then again you have the sequence of this one, and you will find these values for each of them, and then you will find those values for this side. The answer is the best answer for this plus the best answer for this. That's it. That's just the answer. That's just the way it is. Let's be very clear, because if you're trying to form the longest decreasing sequence here, which you can remove using such operations, because you can never remove the maximum wherever it is. If it's in the very beginning, removing that is useless. The argument stays good. So we have to just find those two lengths. We can just write a function that gives us this decreasing sequence. Okay, vector int fun of vector int a returns longest decreasing sequence starting from max and then next max. Not longest decreasing, returns the length of max and then next max and so on. Okay, vector int l of n for int I a. Let me write it like this. Val equals, so this is getting solved very quickly. See, for me, maybe I'm quicker if I don't use this copilot thing, because I can type very quicker rather than checking what they have telling, but maybe not. So we have this value now, and then we have to remove everything that is smaller than this in that list. Okay, we will maintain a vector, let's say, or we can maintain a stack. Everything smaller you remove, and then you can, everything smaller you're removing, and then you can surely push this one. You just need count. Done. You have first maximum, and then you have next maximum, and then you have next maximum, and so on. So now what should we do? We have int n, scene n, we have vector int a, we have this L forward equals to fun of a, reverse of L reverse equals to fun of a. No, you need not reverse. Oh, you can reverse that too. So now int answer equals to let's just say everything decreasing or everything decreasing, which is nothing but LF of n minus 1, maximum of LF of n minus 1, comma LR of 0. That's it. So this one we were able to implement very quickly. See, we were able to brute force it very quickly. Like, I have coded this one very quickly. So guys, I'm still good, I guess. I have it in me. Like, brute force that point, and then the problem is done. Be very clear of what you can remove and what you cannot remove. The problem is done. See, coding problems have very nice solutions. You just have to be clear. This was very simple. That max cannot be removed, and then the next max cannot be removed if you are just focused on that one and then just brute forcing that V point. That was too simple. Should I get some more water? Consider that Simons is given, and you guys get scared of D somehow. Consider that Simon is given an array of size m. Simons must operate on the array exactly once as follows. Has to select an integer k and choose k pairs of integers. Okay, such that Li less than or equals to Ra for each k, L1 equals to 1, or k equals to m, or I plus 1 equals to Li plus 1. So you have to partition that. You have to break that into k non-zero pieces. You get that? Because Li is or equals to that k non-empty things. Then he reverses each subarray independently. After this is a nice problem. For sure, it's a nice problem. I would likely enjoy this one. Like I will surely solve this one. It may not be too difficult for me, but I will definitely enjoy this one. So you have to break it into k parts, and then you have to reverse each of those k parts. After that, the array will become this one. You are given an array T of size and count the number of arrays as such that Simons can transform S to T modulo 998. N is 8000. Can we do n square? Maybe, yeah. 64 times 10 power 6. Values are also less than or equals to 8000. That's a, but only sum of n is less than or equals to that. So maybe you can always do 8000 max value times this one. 8000 times sum of n, maybe not n square but values times this one. That's giving off complexity a bit, but let's think about the problem a bit. You have to count number of ways that can come here by must operating exactly once. Are we given k? If all of them are equal, only one array will be there, right? Any distinct arrays can be transformed into this by choosing some case. We have to think of that. Let's focus on the first thing that will differ from for two arrays. Okay, if you can form this one, if you can reverse this one, okay, number of things that will come after reversing this. You can try to think of such things, right? Okay, after you reverse this one, number of ways you can form this one because k is not fixed. So after you reverse this one, number of ways you can solve the problem, and then after you reverse this one, number of ways you can solve the problem. But you should not count some things multiple times. That's the only trouble you may have. So let's just split this into few different things and then reverse them. That belongs to us, right? Split it into some partitions and reverse each of them. That belongs to us. Number of ways you can break it might be, let's say you're just selecting the n values. You can never select this as end, and you can select is 2 power n minus 1, and each of them will differ. Let's just say how we can brute force this one like DP. Let's try to see, because we have values less than or equal to, take that as hint, and then let's try to see number of ways you can partition till here, and you can reverse shit. Number of things this can be partitions and reverse shit such that this value. So let's say you find that for all prefixes such that this value equals to, by fixing this value, let's say you do that by fixing this value, and all of them will correspond to distinct ones, because once you reverse, yeah, because, or can you have something like only considering this number of different things you can do, only considering till here, and you can impose one other condition on that. So let's try to see by taking two different prefixes, this one and this one, how would they match? If this is being same as this split, that means this and this should be same, right? This and this should be same, and And this and some portion of this should be same. And this and some portion of this should be same. Up to so on. I do that in my PG. I guess I'm streaming again, bro. Should be careful. I'll remember that. It's likely brute force DP, but how do we do that? How do we simplify the problem a bit more? So let's say you have something till here. Till I, you have like number of ways you can reverse such that the lost value differs. Let's try to think of that itself. Now you are here. Okay? And for each of the lost value, you have its positions over there. Right? For each of the value, you have its positions over there. And if that one comes here, what happens? That one coming here, and you want to make that now for these things, okay? That one coming here itself will differ from everything else that's there. Now we have to count that one coming here and this one coming here. Them having same things you have to worry about, right? Have to worry about the cases where this one comes here and this one comes here, and still they match. You have to worry about these things. This color coming here, and that color coming here, right? How can you uniquely write them? How can you uniquely write them? So you're trying to split them, right? Till I ending with val. We're just trying to do the basic brute force DP because the problem is just G, right? It should not be much difficult. Basic DP should work. So now we have this val that comes here after you flip. So what does it mean if two suffixes have same things? This one and this one. And how can you avoid this? How can you split those things? So this thing turned here and then you got that value and then you got that s, and also this thing turned here and you got that value. Let's say like val from here, you have some array where val from here came and val from here came. They may have those intersections, right? But how can you define it in a way that what does it mean like if val from here coming and val from here coming matches? So this reverse equals to this reverse, right? So all these values should be equals to all these values in some sense. Can we find the largest val that matches when flipped? Because now we have these things where this can come and this can come. What if I define like subsequences that can come when you flip this, but they cannot come if you flip anything larger? All the things that can come when you flip this, but they cannot come when you flip that one. How do you define that? It's getting weird. It's not that difficult. It should not be that difficult. It's counting. How can you count them in a unique way? Let me read F2. And there are n cross m crossroads in the city named. The first number represents the row and the second number represents the column. There exists only. So you want maximum beauty among all nice reconstructions. This seems to be a nice problem, right? I'll try to think of this one too. This one is somehow brute force DP. I have to think of that. I should not waste time. I have to come back to that too. In 1 hour, can we solve one of these two? Is our question now. We want maximum. So I think this is definitely DP, but counting DP, like we have to find a unique way to count them. Like we have to represent them in a unique way so we can count them. But this is finding minimum, maximum beauty. So if we can find some upper bounds, maybe we can have something here. So number of things that are reconstructed, number of red things for each of them should be even, right? Number of red things for each of them should be even. That means you can split the graph, you can split the red graph into Eulerian cycles. Okay? And once you do that, okay, so this one has plus minus, this one has plus minus, this one has plus minus, this one has plus minus. So if everything can be decomposed into cycles, disjoint cycles, and cycles in here will look nice. So all of them will have even number. So for all of these things, you will have an even number of things that can be taken. Right? I'll try to see those things properly. You have to say some upper bounds here. And then the tightest upper bound will be the maximum beauty. So if all of the weights or even all of them can be all the edges can be decomposed into even, like this will be even number of things, this will be even number of things, this will be even number of things, this will be even number of things. So answer is less than or equals to, look at each row. Maximum value of alternating sum is an upper bound on its contribution. Okay, so if there was some cycle possible with just this one, then but if we're too drunk to try and the music is right. You can have a cycle and then you can have an inside cycle. This also looks like DP. I don't know which one to choose. How can you show that this is optimal? Like, Oh, my screen has been gone. I don't know when. Trying to think of F. The children to try. How can this be thought? These things can only be positive, okay? Is there anything nice here? Is there anything nice? There can be only one cycle. Hmm. Till 10:30, I guess. You having now? Hmm. I don't think I can solve, but at least I want to solve. I don't think there's anything nice here. It's likely brute forcing DP, but how do you brute force DP? Can you do something like answer finding answer for this using answer for some smaller sequences? Let's say these are the structures that you find answers for. Can you find answer for this by try using for answer of something smaller? Think of that. You have answer for this, right? And now try to brute force these two states, okay? Because these are the new things. If you try to brute force these two things, if this is even and this is even because this is plus and this is minus, you know their signs. Because those are the last ones, you know their signs. And based on that, you have to find answer till here for this one where you bother about these two having even or odd degree. For this, you bother about these two having even or odd degree. Now, can you find answer for till here where these two having even or odd degree? This is having even or odd degree, and rest even or odd, and everything else is even. Now, can you find the answer? Now you have to brute force this one, and you have to brute force these pairs. That will be O 4, and then brute force these edges, and based on that, these three things will have different parities. Who's trying to sell you something that you already have? But if you're too drunk to drive, and the music is right, she might let you stay. I can live without this problem now. Because I wanna see how this can be solved. I'm not implementing, but I'm just trying to. And then I'm trying to join that stupid online video. Like, Satya told me, yesterday, see, we have to solve a problem in the assumption that there is a simple solution. We have to use that assumption somehow. We have to use that there is an assumption that there is a simple solution. So let's try to investigate what happens if you look at, I mean, that those looks complex, but maybe there is something that makes them simple. Maybe there is something that makes them simple. Let's try to look at two cycles that intersect. Okay, let's try to look at two cycles that intersect. What can we say about them? Let's say this is plus, this is minus. For an individual cycle, we'll keep this is plus, this is minus, plus, minus, and these are also plus, minus. See, the problem doesn't seem okay. Let's see. Let's say only this one cycle here and one cycle here, one cycle here, one cycle here. See, is it either DP or there is something nice in this one, right? It's either DP or there is something nice in that. Uh, let's try to see like what's the complexity. Let's say if we have such cycles that are possible somewhere, because those can definitely be split into disjoint cycles, right? Let's say if these are the cycles that are possible, uh, for each of them we have to take their sum, and if the sum is positive we should not flip them. If the sum is negative we have to flip them. That will give a value. Let's think of this one, like if two cycles are intersecting, let's have their independent score. Okay, the first time this will be plus, this will be plus, and this will be minus, this will be minus, right? If you look at some things like this. All of the cycles can be split into disjoint cycles is one thing, okay? And how does disjoint cycles look like? They can only share vertices, right? Disjoint cycles will look like something like this. They only share vertices. So disjoint cycles, wait a minute. There is a way to split things into disjoint cycles, and who's trying to sell you something? One claim is you can always split them into disjoint cycles like this, cycles that never intersect, okay? And if you're having cycles that never intersect, you can individually add their values up. So the claim is anything can be split into cycles that never intersect, okay? What does intersect means? What does intersect means? Cycles where they cannot pass through. What does that mean? You cannot have this one green and you cannot have this one red. So let's say these are two cycles, okay? Let's say this is green and this is red. If such things are not allowed, let's try to brute force these structures, okay? Let's try to brute force the structures that never intersect, that never ever intersect. If you try to see those structures, you can always split you can always split them into, like, that is one claim. You can always split the things into cycles that never intersect. But can you brute force this structure now? Cycles that never intersect. Can you somehow brute force this structure? Think of that. See, I think anything can be split into cycles that never intersect, that never pass through each other. and this will at least break things into individual, like, and now you have to just, among all possible splits, you have to find uh, some are negative, some are positive. At least I have a mathematical answer now. What is my mathematical answer? So it's disjoint cycles that has positive sum is the perfect answer. Disjoint cycles, sum of negative cycles and disjoint cycles. It's being too difficult for me. Come on, these things are too much. How is it having 191 solves? What the fuck? Think, think, how can you find those things? Is this the logical simplification? Can you simplify it further? Is there something more nice in there? I don't think there is. Now let's look at negative cycles, okay? Think of some heuristic algorithm, find maximum negative cycle and then remove that shit. Who's trying to sell you something? Something that you already know. But if it to drive, and the music is right, she might let you stay, but just for the night. May not be right because if you take this one, you cannot take this and this, right? But if this is negative and this plus this is more negative, that means this is negative, this is negative. Can this be maximum? Think of that. Because this plus this is these two things. Maybe not. Maybe there is some logic. I am not able to figure that out. Okay, now can you find maximum cycle? Maximum negative cycle. Can you find that? Wait, can you make anything that cannot be taken as zero so that its effect will not be there? But then you can form cycles that cannot be formed. That's wrong. Can you view cycles as connected components of this plus this plus this, connected components of this plus this, and so on, where for each thing plus minus, so connected component of that. So each node will have a value of plus minus, and then you want to find connected components. Now instead of cycles, you want to split that into connected components, groups. But then not all are positive here, right? And you will take weights of these things as minus infinity. Whenever you apply that to this one, you will take weights of that as minus infinity, but when you apply to this one, but if you're too drunk to drive and the music is right, she might let you stay. Don't you notice how I get quiet when there's no one else around? Me and you and awkward silence. Don't you dare look at me that way. See, I've thought of too many ideas. Most of them are good, like most of them are correct. Like you can have a case where you can only form these independent cycles and all of them should be negative. Is the maximum cycle correct? Is the maximum negative cycle correct? Maybe it is correct, I think. Okay, if I try to find the maximum cycle, that's negative. How do you find that? I'm ending the stream, guys. This is too much.